Welcome to ATI and Honor Code System of Systems course. It's a two-day advanced course on technical leadership in a networked world. As far as I know, it is the only course on system of systems available out there because it is a new topic, and it is by far the most advanced course I've ever taught. Course objectives: understand the nature of system of systems and how they differ from normal systems with the degree of complexity and with the lack of control in some. We'll also learn to identify and analyze key relevant features of a system of systems, because it turns out there's various levels and types of systems that deviate a little bit more from traditional system engineering as you get to things like the internet as a system of systems. Learn different methods for architecting system of systems, because that's part of how we can deal with these complicated system of systems that are coming out. Learn practical tools for integrating systems. Learn how to work in disjointed teams that develop system of systems, because teams are not like the old days where you had very military type chains and all that in these system of systems. And learn effective means for test and evaluation of system of systems. In the two-day course, this is the material that we'll cover: an overview of what's going on and what is system of systems, some of the challenges and complexity, the research behind system of systems, which is fairly new, the architecture solutions. We'll have you practice your system of systems knowledge on a smart highway system of systems. We'll give you some architectural solutions that can help, also some integration solutions. We'll go back to the smart highways to make sure you understand better those integration solutions. We'll also talk about some collaborative solutions and some test and evaluation solutions. And all the way through, we'll be kind of following along with the lecture with a group exercise in order to reinforce that system of systems for a smart highway system. This shows you this medium complexity smart highway system that we'll be dealing with. Even in this, you can see how quickly there's quite a few interfaces, quite a few challenges, quite a few systems that have to deal with other systems, which may or may not be the same chain of command. We'll talk about different levels of system of systemsness, where you have, I mentioned early on, the high level of system of systems, the most difficult for traditional system engineering think that started back in World War II, a virtual system of systems like the internet. We'll also deal with the lowest level of system of systems, closer to traditional system engineering, directed, and in between we'll talk about collaborative and acknowledged. And there is different techniques that you may use and different amounts of tailoring from traditional system engineering that you would do in each of these types of system of systems. This particular slide came from DoD, but we've enhanced it too to talk about some research that came out of the Dancy study, and showed some specific examples of the various categories of system of systems. And part of the factors that influence it is the operational independence. Do these system of systems need to operate independently of each other? The managerial independence, is anybody really in charge like the internet? In that case, no, but we also use an example like a emergency response. Let's say if there was something that happened at a national airport, you could have the federal government involved, the state government involved, the county, city government involved, firemen, policemen, etc., and they all have their own independent management, but they would like to work together in that scenario. The evolutionary development of system of systems, the fact that each of the systems of them may be developing at different speeds and different orders. The emergent behaviors, sometimes when you put things together, there's things that are happening that nobody could have predicted that are both good and bad. We'll talk about emergent behaviors and the geographical distribution of the system of systems. We'll talk about the impacts of system characteristics. We just talked about some of those characteristics. It gets back to insight into the structure. You don't know what's inside the black box for parts of it. Lack of control for the person that's trying to look at all the systems working together. Constant revisions and integration issues. Stakeholders' wants and assurance that the emergent behavior will be dealt with appropriately. And difficulty controlling and timing these interfaces. So this traditional World War II control of systems and system engineering now with various levels of systems becomes much more challenging in this course. And I hope you get a chance to take this very advanced course on system of systems, and it's the future with more systems becoming more interrelated and more levels of systems having their own purpose, and then also part of a system of systems in a particular situation, and with the increased complexity of these system of systems. Thank you.